Our current challenge is to find the zeros of each of these quadratic functions. And so the first thing to do is recall that each of these terms are synonymous. In other words, a zero, an x-intercept, a root, all mean the same thing. They're where the graph of the function intersects the x-axis, or correspondingly when the y value, the places where the y value, y coordinate, is 0. So we know for a function y equals f of x, or g of x, or h of x, or whatever. To find the zeros, let f of x equal 0 and solve for x. So in the first case, A, we have g of x equals x minus 1 quantity squared minus 4, and we'll let g of x equal 0. So now we have x minus 1 quantity squared minus 4 equals 0, or x minus 1 quantity squared, adding 4 to both sides. Now, we're not going to square this out. We'll use the square root property, which tells us that x minus 1 equals plus or minus the square root of 4, which is 2. Now, adding 1 to both sides, we have x equals 1 plus or minus 2. So x equals 1 minus 2 is negative 1, and 1 plus 2 is 3. So the zeros are x equals negative 1 or x equals 3. And in terms of coordinates, we would have negative 1, 0, and 3, 0. And now we'll move on to the next issue. Well, to find the zeros for f of x equals x squared plus 4x plus 2, we'll complete the square. And of course, the first thing we'll do is set f of x equal to 0, so that means that x squared plus 4x plus 2 equals 0, and as I said, we will complete the square to find the zeros. So in order to do that, we need a perfect square on the left. So let's get rid of that 2 for the moment. So we'll subtract 2 from both sides. And now, to complete this square, we know that the final term has to be the square of half the coefficient on x. So half of 4 is 2. If we square 2, we get 4. So I'll add 4 to this side, and in order to maintain the equal sign, then I must add 4 to this side. So now we have a perfect square on the left, and that is x plus 2 quantity squared, and that equals, well, minus 2 plus 4 is 2. So we're not going to square this out. We'll simply use the square root property that tells us that x plus 2 equals plus or minus root 2. And now, isolating x, we get x equals, subtracting 2 from both sides, negative 2 plus or minus root 2. So the zeros occur at x equals plus or minus 2 plus or minus root 2, and those corresponding points would be negative 2 minus root 2, 0, and negative 2 plus root 2, 0. And time for the next one. Now, to find the zeros of the final equation, h of x equals 2x squared minus 5x plus 3, we'll use the quadratic formula. I hope you can read that. And which gives the 0 for any function, quadratic function of the form f of x equals ax squared plus bx plus c, and where the zeros are, x equals minus b, that b right there, plus or minus b squared, that b right there, minus 4ac, and that's the square root of that b squared minus 4ac, and all divided by 2a, that a right there. So now let's find the zeros of h of x using the quadratic formula. So x equals, now in this case b is -5, so a negative times a negative is a positive, plus or minus the square root of, and we'll square b, so -5 squared is 25 minus 4, a is 2, and c is 3, all over 2a. Now a is 2, so 2 times 2 is 4. So that equals 5 over 4 plus or minus, and it turns out the product of 4 times 2 times 3 is 24, and over 4, which equals 5 over 4 plus or minus, and the difference of these, 25 and 24, is 1, and the square root of 1 is 1, and that's over 4. So now we simply have to sum these fractions, and 5/4 minus 1/4 is 4/4, and 5/4 plus 1/4 is 6/4. And reducing these, we get 1 and 3/2, and these are our zeros. X equals 1, or x equals 3/2. Either way, those two values of x will take that function to 0. The corresponding ordered pairs are 1, 0, and 3/2, 0. And we're done.